look at how to write inequalities from a word problem. When writing inequalities, start by writing a let statement to define the missing information. Then write your inequality, solve your inequality, and finally write a conclusion statement. Here are some key terms that indicate which inequality symbol you would need to include in your word problem. It is common to misinterpret a few of these, and I want you to highlight these in your notes. The less than or equal to symbol can be described with the phrase is no more than or is at most. These two often confuse people because of the words more than and most. When we read these, we tend to think greater than, but if you put them into context, if you can have no more than, let's say, 3 cookies, that means you can have 3 cookies or less. Hence why it's the less than or equal to symbol. Same thing with the phrase at most. If you can have at most 3 cookies, that means 3 or less. Similarly, the phrases no less than and at least are often confused as less than or equal to symbols. However, they represent greater than or equal to. If you need to complete no less than 5 problems on your homework, that means 5 or more. Or if you need to complete at least 5 problems, that also means 5 or more. So be careful with those 4 and be sure to refer to your chart to help you determine which symbol you should use when writing from a word problem. Let's take a look at a few examples together. If Dan sells vacuum cleaners and he earns $100 a day plus $12 per vacuum that he sells, how many must he sell to earn at least $250? Before we begin, first circle the word or words that tell us which inequality symbol we should use in this problem. The words at least tell us that we must use the greater than or equal to symbol to solve this problem, because if he needs to earn at least $250, he wants to earn more than or equal to $250. Next, let's write our let statement. Since we're trying to figure out how many vacuums he must sell, X is going to represent the number of vacuums he must sell. Since he wants to earn at least $250, we're going to say he wants his earnings to be more than or equal to $250. His earnings are going to be represented on the other side of the inequality. We already know he earns $100 a day, and he also earns an additional $12 per vacuum. So that would be 12x. Our inequality would look like this. 100 plus 12x is greater than or equal to $250. To solve this, you would first subtract 100 from both sides, leaving us with 12x is greater than or equal to 150. And finally, divide both sides by 12, giving us a total of 12 and a half. If we look back at our let statement, we know that our let statement represents the number of vacuums that Dan must sell. However, we got an answer that is 12 and a half. Since you can't sell a half of a vacuum, would we round up to 13 vacuums or down to 12 vacuums? If you said up to 13, you would be correct, because we want to make sure that he earns at least $250, so we don't want to round down because he would not earn that $250 if he sold less than 12 and a half vacuums. So our conclusion statement is going to be Dan must sell at least 13 vacuums. It is very important that in your answer, you include the key phrase that you identified in the original problem. We do not want to say he must sell 13 vacuums. He needs to sell at least 13, which means 13 or more. Let's try another example together. Ariana is buying bread and cheese to help make sandwiches for a family picnic. She can spend no more than $20. She bought a box of crackers for $3.50. She wants to buy 4 blocks of cheese. What is the most the cheese can cost? The key word or words in this problem are no more than $20. That tells us she wants to spend less than or equal to $20 total. Since we're looking for the cost per block of cheese, that is what our missing value is. She has already purchased a box of crackers for $3.50, and she's buying 4 blocks of cheese at X dollars each. To solve, I will subtract $3.50 from both sides, which leaves us with 4x is less than or equal to $16.50, and dividing both sides by 4 gives us an answer of $4.13 per block of cheese. So we need to write she can spend no more than, again using that phrase we circled above, $14.13 per block of cheese. Take a few minutes to try writing your own inequality for each of these examples. In this first example, it tells us that Cole wants to spend less than $375. Since he's being charged $150 for parts and $60 an hour, our equation or inequality would look like this. In the second example, you want to earn at least $600. If you earn $150 shoveling snow plus $10 an hour at Giant Eagle, you want to earn more than or equal to $600, your inequality would look like this. Let's try this last example together in your notes. A freight elevator can safely hold at most 2,000 pounds. Joe and Barry were asked to take a set of 30-pound boxes to a storage area. If Joe weighs 185 pounds and Barry weighs 210 pounds, what is the most number of boxes they can safely move at one time? A key word here is at most. That means less than or equal to 2,000 pounds. Since we're looking for the number of boxes, we would let x equal the number of boxes. And this is going to be per elevator ride or per trip. If we know that each box is 30 pounds, that's 30 pounds per box times x boxes. Plus Joe himself and Barry also need to be included in the weight because they are on the elevator as well. To solve, I would start by adding 185 and 210 to find the total weight of the two men. 30x plus $395 is 395 pounds is less than or equal to 2,000 pounds. Subtract 395, which gives us a total remaining weight available of 1,605 pounds. if I divide that by each 30-pound box, we get an answer of X is less than 53 and a half boxes. Similar to the first example, we obviously can't have a half of a box. However, the difference between the first example and this example is that we do not want to exceed or go over the weight limit. So although 53 and a half technically rounds up to 54, in this specific example, because of the problem, we actually want to round down to 53 boxes only, because we do not want to go over the weight limit. So our answer here would be they can move at most 53 boxes at one time.